Malatesh, sir, we can start, I think.
Yes, sir. Yeah. Hello. So audible, sir, now?
Yes, sir, audible,
Yes.
sir.
Thank you,
Please
sir.
go.
Thank you. Yeah, I was explaining these pins. This is the power indication. There's a whenever we connect for the Arduino, it shows whether the power is there or not. And this is the reset button. Uh, Once you press this, the program will start running. Okay, so we'll discuss about the program a little bit, which are the sections are there and so on. So we can once we reset it, it doesn't mean that the program will be erased or not. It's not something like that. So the program will start to run once again from the beginning. That's all. A few are joining, so just I'm going to allow them. Yeah. So just now what we discussed, all those the features with what are there is going to be shown in this slide. It is going to operate with the voltage just the 5 volts. That is for the microcontroller, just 5 volts is enough. But we supply 9 volts to 12 volts. But internally, there is an IC which converts the 9 volts to the 5 volts. I think you know there are some the voltage regulators are there, which is 7. For example, 7805 is the IC which converts the any higher voltage more than the 5 volts to the 5 volts. Such connections will be there, and the recommended voltage for the Arduino is we can connect from any voltage from 7 volts to the 12 volts. Uh, and the input voltage range from the 6 volts to the 20 volts. The input voltage in the sense for the A to D converters, we can connect the any voltage from lower voltage to the higher voltage. It is capable of converting those into digital, and it has the 14 IO pins are there as we discussed, and 6 analog pins are there from A0 to A5, and each input and the output pin, whenever we configure accordingly, it is capable of the handling of 40 milliampere of the current, and the DC current of 3.3 volts. When it is the 3.3 volts, it is a 50 milliampere. Please don't use the annotate there. Please remove it. And this is the flash memory around 32 kb, and SRAM of 2 kb, and EEPROM of 1 kb, and the clock speed is 16 megahertz. So this clock is very important. Will generate the clock by a crystal oscillator, which all the operations are of the any processor or synchronized with this clock. So I think we know whenever we go to buy any system or laptop or any mobile, we try to look at the speed. The speed is in any, but the clock speed always we talk about. This is the actual pin configuration of the Atmega 328, the microcontroller. These are the same, most of the concepts we have discussed it. Uh, Later you can go through it. Uh, Now, what are the applications? I'll come to this part a bit later. So, what are the applications of this Arduino microcontroller? Means using this Arduino microcontroller, the different versions of the Arduino, what and all we can use. Let's see the applications. I'll come back to these slides a bit later. Yeah, the applications. So these are the some of the applications what we can build using this Arduino, or any versions. See, this is robotic dog, obstacle avoidance robot using ultrasonic sensor and servo motor. Multiple ultrasonic sensors we can connect. This is a line following robot. Snake, cleaning robot or sweeping robot we can say. Bluetooth controlled robot, watering robot for the gardening, pick and place robot, the humanoid robot, traffic light control systems, home automation. This is the home automation using relay and just the loads are just LEDs. Instead of these LEDs, we can connect the real time devices like fans and all, bulbs and all. Motors also we can interface. Like IoT projects also can be done using this Arduino microcontroller. This is another IoT project. Is nothing but uh, wireless notice board, which uses the GSM module. Quadcopter or drone, and virtual reality in the sense, depending on the movement of our hands, the objects also can be moved or the cursor can be moved. Uh, well, these are the, not only these, once you get some ideas, definitely you can do different the projects or applications using these. Now I'll start. How to start with this? The Arduino is very important. Of course, in these sessions, coming sessions, we can't do all these projects and all, but we are going to explain the few of these. Now I'll explain how to start to work with the Arduino. It is very important. Uh, these are some of the steps, the basics. First, we have to download the Arduino environment, that is Arduino software from the Windows. It is a open source, so we need not to pay for the software, but we have to pay for only the hardware, the components. It is open source, and many projects codings also available on the website. You can download those later and practice. And once we download the Arduino, we have to connect to the USB cable to the Arduino hardware. Then we have to install some of the drivers. These drivers are required to interface the IO devices, and we have to launch the Arduino IDE, and we have to select the board like or Mini, or whatever the boards we are going to use, and we have to select the serial port. Whenever we connect a device to the PC or the uh, desktop using the USB cable, it will show to which serial port you have to select. So you have to do that, and we have to write a program, and we have to verify it. Verification in the sense, I think most of the computer science and the electronics teachers will be knowing. we have to run a program, we have to write a program, and we have to compile it. The compilation is nothing but the converting the high-level language into the machine language or the binary language. That has to be done automatically here. We can do, and we have to upload. So once we upload, it starts running. So any embedded system will have the program in the firmware, uh, which is loaded into the ICs or the memory ICs, which start running continuously. So such concepts will be there. Now I'll explain. This is the basic the Arduino Uno. It is going to be connected to the USB cable, and this is uh, the Arduino IDE. The environment how it looks like. You can see here the selection of it looks when we open the Arduino IDE. This is the space where we write the program. Before writing the program or after writing the program, you have to select the serial port. This is a COM port. You can see COM1 and COM2. It will show automatically whenever you connect the hardware, the Arduino board to it. You have to connect, and this is the board selection. You can see whether it is uh, Atmega or the Arduino Uno or Mega. You can see all these. Whichever the device you are going to use, you have to select it. It's very simple. Go to the tools and select the board, and it will show these many uh, devices. You have to select a particular device which are you using, and you have to go to the again same tools and select the serial port and connect it. These two are very important parts. Okay, so before transferring the program. Unfortunately, now the hardware is not there, but I'll show you how to the simulate in the Tinkercad a bit later. So these are the steps. Just now what I explained. Uh, Uploading the worked and wrong serial port. If anything is wrong in the coding or selection of the board or selection of the ports and all, so you'll see some errors. It will show, and you have to rectify or debug and continue with the same. These are the simple steps. That is, should write the program and compile it and upload. And during the upload, and there will be, as I said, the transmitter and receiver will be the blinking, which gives an indication of the transmit of the bits of the program from the laptop to the board. This is the LED connection. The first as a first program in most of the IDE, there will be some example programs will be there. I'll show you how to see, but hardware is not there right now with me. I'll simulate it later, but actually how we can run a program, I'll show it bit later. As a first, the program. See, we call it as a blink program. Usually, whenever you start working with the hardware, you will have the ready-made. The program will be there. Just you can compile those and upload and see how the Arduino works and all those things. Now, this is an LED. It has a cathode and the anode will be there. You know, whenever we make the LED forward bias, it starts conducting, and the current voltage will be applied across the LED, and depending on the voltage, the current start to flow, and the intensity of the LED is based on the amount of the current flow which flows through it. So that all here you can see one of the connection of an LED. This is an LED here. It is connected to this is the ground pin, okay, and this is pin number 13. So as I said in the beginning, there will be one inbuilt LED will be there. This is an inbuilt LED, or we can connect the external LED also. That is also possible. Once we connect the ground to the cathode, and any one of these. As I said, there are 14 digital pins are there. Once we call them as digital pins in the sense, uh, the voltage will be either 0 volts or 5 volts. Okay, but these are the analog pins. The voltage for these may be either 1 volt, 1.5, or any voltage. So which is the analog voltage that will be converted into digital internally. But for these, the voltage should be either 0 volts or the 5 volts. So once we connect input device, it should send either high voltage or low voltage, that is 0 volts or 5 volts at any moment. And once we connect the output device, for that output device, these pins will supply either 5 volts or 0 volts. So those 5 volts and 0 volts are going to be considered as a 0 and 1, as already we know. Usually in the post logic, the 5 volts, which is the higher voltage, is taken as logic 1, and the lower voltage, which is 0, is taken as logic 0. Okay, fine. You can see for this one LED is connected between the ground and pin number 13. Okay, for this I'll show the program. There is a path. Uh, yeah. As I said, there will be some inbuilt programs will be there. Should go to the file. Once we open the Arduino IDE, should open the file, go for the examples, and then select the digital, then blink. Means in this the examples, so many examples will be there. With respect to digital, go for a particular program. So the program name is what? The blink. The blink, the name is given to this program because this, once we run this program, this LED will blink, means it will become on off with some delay in between, like 1 second, 2 second, 3 second, or 10 seconds, or minutes also we can do with multiple inner loops. Yeah, this is uh, the space we write the program or IDE environment. Every program will have two blocks will be there. We call one block is the setup block and loop block. In setup block, we try to configure which pins we are using. So which pins of the Arduino we are using this particular project or particular program. Some pins we can use them as the input pins or the output pins. Means when we connect some input devices like sensors and all, it may be temperature sensor or light sensor or the whatever the sensors are there. We have to connect them as those to the input pins or the input ports. So we have to select certain pins and configure those as the input pins. And if you want to connect some output devices like the actuators, maybe LED or buzzer or LCD, whatever it is. So we have to select certain pins, which pins we are using, and we have to configure them as the output. So I'll repeat once again. Every program will have the two sections or two blocks. One is the setup block, the other one is the loop block. In setup block, we try to configure the pins as either the input pins or the output pins. Means which pins are, suppose we are using 10 pins or 5 pins and all. I can use 5 pins as the input and 5 pins are the output. So which are the input pins, which are the output pins and all, we have to configure and put in this block. Okay, there are certain instructions are there to configure certain pins as the input and output. I'll show them later. And the other block is a loop block. This loop, in the sense, the whatever the instructions we keep or the program will keep in this loop, that keeps on running continuously. There is no end at all. So say for example, the temperature sensor, so it has to sense the temperature uh, and convert the physical temperature into the voltage, and the microcontroller keeps on reading it continuously, either after every 10 seconds or 10 milliseconds or 5 minutes or something like this. Say for example, in a room I want to control the room temperature between 25 degrees centigrade and 30 degrees centigrade. So should not go beyond 30 degrees centigrade, should not go beyond below 25 degrees centigrade. So for such project, a sensor will have to be used, and that sensors should send the information to the controller. It has to sense continuously. That depends on for how much minutes or how much time I give in the program. So such programs will have to be set in the loop block. Okay. So as I said, in setup, we configure the input and output pins. It will be run only once in the beginning, but later the instructions which are written in the loop keeps on uh, running repeatedly. So as long as the device is on. Okay, fine. Hope it is clear. You can see in the left box, this is the setup block, and this is the loop block. This is not visible properly. I'll show you. So how the sections will be there. And these are some of the terminologies what we usually call them as. This is the sketch. The program what we write in the Arduino environment is called as the sketch. The together, the setup block as well as the loop block together is called the sketch. And pin, already we have discussed, maybe input pin or output pin. And the digital, in the sense it will be either high voltage or low voltage. It may be the voltage from the input device, or it may be to the output device. Okay, so always it will be high or low. High means 5 volts and low means 0 volts as usual. And analog, in the sense it can be varied from 0 to 255, in the sense from usually this microcontroller is 8-bit microcontroller. 8-bit, in the sense it may be the combination from 8 zeros to the 8 ones. Like you write the binary, I think most of you know. With 2 bits we can write 0001 1011. In the same way, 4 bits 0000001 0010. Like this we can continue all four. The same way, the 8 bit controllers will have to change from all 8 zeros to 8 ones, which if you convert them into the equivalent decimal, it will start from 0 and 8 ones, nothing but 255. Yeah, this is some of uh, the commands. As I said, we have to configure some of the inputs as the input port and the output port. This is one of the command we should using which we can configure a particular pin as the input or the output. Say for example, I want to make the pin number 13 as the input or the output. So we should write the pin number here. That is a pin mode. This is case sensitive. P should be small letter and M should be the uppercase. Okay. The pin mode 13 I should write here, and if I want to use it as an output pin, I should write it as the output. See, the possibilities are what? Either input or output. So the mode is either input or output. This pin may be the any number or the name of that particular pin. In the beginning itself, we can give the name for the pins also. Let us see which are the different techniques of the configuring the pins as the input and output later in the some of the programs. So this is the command or the instruction to configure a particular pin as the input or output. And this is the digital read, in the sense this instruction will read the information or the analog signal from the particular the analog pin and convert it into digital. So you can observe here, this is the pin number. So it may be either high or the low. And digital write in the sense sending to a particular pin either low value or high value. Again, low in the sense always it is 0 volts, and high in the sense the 5 volts. So it will read from a particular the sensor or the input device either high or low, and this will the send for a particular pin either high or low. Okay. These are the time delays in between. We can give millisecond delays in between or microseconds. If I want to give 1 second delay, I should mention it to 1000 milliseconds. Let us see some of the programs a bit later. This is the LED, how we connect. To connect the external LED, say for example, this is an LED, sorry. Yeah, this is an external LED. This is the cathode and this is the anode. This is the cathode is connected to the ground. So if this LED has to glow, we have to send high voltage for this, means through a resistor to limit the current. This is the anode. Anode should be connected to the high voltage. That is a 5 volts in this case. So since I'm going to use the pin number 13 here, so for an LED, for the anode should be connected to pin number 13 through a resistor. Okay, and this cathode should be connected to the ground. So when the microcontroller sends a high voltage, that is a 5 volts to this LED will glow. Otherwise, if it is 0, this LED will be off. So if this is 0 volts, it will be off. If it is 5 volts, it will be on. So this is on the right side, another the configuration. See, this is the 5 volts, means already to the anode, the 5 volts is connected, and this the cathode is connected to pin number 13. So to pin number 13, we can connect either anode or cathode, but depending on, I think you have heard about the common anode type and common cathode type. So here the anode is the common, which is connected to the 5 volts, and resistor is connected, and pin number 13 is connected to the cathode. So in such scenario, when pin number 13 is low, this LED will glow, which is opposite to the previous concept. Okay? So in most of the cases, we use this left side configuration. Yeah, this is the program to blink program, what we call it as to blink an LED. As I said, it has two sections are there for any Arduino program. The setup block and the loop block. Okay, so here you can see these are the comments. As usual, like basically we use the language either a C program or the C++ for the Arduino. Okay, who knows C? It is very simple. Who don't know, if you glance at the blocks and all, it will be easy for you to understand. So usually all the program you start with the open brace and the end brace. This is the setup block, and this is the loop block, the start and the end of the program. Fine. This is, as I said, in setup block we try to configure the which are the input pins and which are the output pins and all. For this blink program, I'm going to use only the pin number 13. For pin number 13, we're going to connect an LED. So we have to configure it as a output, because for pin number 13, we will send either 0 volts or 5 volts. 0 volts means low, 5 volts means high. Okay, so this is the command pin mode 13 output, means you're going to configure the pin number 13 as the output pin. That's it. Okay, in the loop block, we write the program. You can see the first statement. This is the syntax to write. We have to follow the same, the wide loop, and this is the wide setup. Okay, digital write means since it is a blink program, we have to send either low voltage or high voltage. Means we have to write every time. Write in the sense send the signal. Okay, the voltage. Here digital write pin name, that is pin number 13 high, means 5 volts. So you can say this is the command line. The command line will be either double slash or slash star. Start with this star slash forward slash star, and as usual star slash, means so whatever we write within these two blocks, so those commands will not be executed at all. Okay, so only this statement is going to be executed here. So here also this is going to execute. The lines after this double slash are not going to execute, as already we know. Now this is a delay. I'll repeat once again. Digital write pin number 13 high, means it is going to send, the microcontroller is going to send the high voltage to pin number 13. So when pin number 13 is high, the LED will glow, in the sense on. A delay of 1000 millisecond, or 1000 millisecond in the sense it is 1 second. So delay of 1 second. After 1 second, execute this instruction. Digital write means send low voltage to pin number 13. So when low voltage in the sense 0 volts to the anode of the LED, it will be off. So now this is the 1 second delay. So again, it comes back to first instruction in the loop. It will never go back to the setup. So as I said, in the Arduino board, there is a reset button is there. Once you press the reset button, then again it will start executing from this wide setup and will enter into the loop. Once it enters into the loop, it keeps on rotating in this. Okay, so in the loop. So first send high, it will be on, 1 second delay, off, 1 second delay, on, 1 second delay, off, 1 second delay, and again send. So it keeps on circulating in this the particular loop block. This is ND. This S is actually it is from here. It has come here. Seconds, 1 second in there. So actually the open brace, and this is the closed brace. That's it. This actually will look like inside the Arduino environment. The program will look like this. There is a setup block, and this is the loop block. Here you can observe now. Yeah, as I was telling, we should write the program. Once you open the IDE, the blank page will be there. You have to write the program like this, and this is the save will be there. Whenever you bring the cursor near to this, it will show the save it. You have to save it, and this is the verification. That is a compilation. You have to click this. So once you compile this, the program will be converted into high-level language into machine language, and using this tab, you have to upload it. Okay, and these are the new to open the new file and all those things. So I'll show you, because this is I think we are running out of the session. It is a very short period. I explained the basics In the next class, I'll explain how to use this Arduino, how to write the program, and some of the simulations. I think the time is less than a minute, I guess. Any questions? Thank you so much. Aman Basraj, sir?
So, hello, sir.
Yeah.
This is Ravi Jedi from remote sensing background.
Yeah.
Yeah, actually, I want to know, do